A piecewise function is a function built from pieces of different functions over different intervals. Each subfunction applies to a certain interval of the main function's domain, a subdomain. Okay guys, so the unit I had to present was piecewise functions, which aren't too complicated, and I'll just guide you guys through it here. So the first problem is a pretty easy one. It says find f of 2 for the given function. And you can look at this and tell pretty quickly that this isn't going to matter because it's x equals 5, and 2 is obviously not greater than 5. So we'll know that we need to use this particular problem. So if you plug this in, negative 2 times 2 squared, so because you plugged in the 2 for the x, and then you subtract 2. When you do this, you'll do the work here, and then you'll finally get it down, and the answer will be negative 10. So that one's pretty simple there, not too difficult for you. Problem number 2 is a little bit more complicated because it takes some thinking. So is this function continuous at x equals 4? And there might be some confusion at first because we can tell here, since it's less than or equal to 4 and just less than or greater than or equal to 4 and then less than here, that there's going to be some sort of change in the graph there. But the easiest way to do this is just to plug 4 into both of these equations and see what we get. And if they don't equal each other, then it's not continuous there. So if you plug 4 into the first equation, negative 4 times 4 plus 7 will give you negative 9. And 8 times 4 squared will give you 128. So obviously, those two don't equal each other, which will make this function not continuous at x equals 4. The final problem here is a graphing one, which is going to be a little bit more complicated, but shouldn't be too hard. So the way that I like to do this is I'm going to start with the lower values. So I'm going to take a couple of points that I know are less than 4 for to graph the first one. And those are my x values, which you'll see here. And then in order to find the f of x, all you have to do is plug these values into this equation. So if you plug 0 into 2x squared minus 6, that'll be 0 times 2 minus 6, which is negative 6. If you plug 1 in, it'll be 2 minus 6, which is negative 4. If you plug 2 in, 2 squared is going to be 4 times 2, which is 8, minus 6, which is positive 2. This was my mistake. And then if you plug 3 in, 3 squared is 9. 9 times 2 is 18, minus 6, which will be 12. And then this doesn't matter because it's not equal to. For this next part, if you plug in 4 for the thing, it's just going to give you 5 because you can see here that x equals 4. And when that's true, that the y value will be 5. So that's all we need to do really for that one. And then finally here at the end, we'll plug in the values for the x's greater than 4. So we'll plug in 5, 6, 7, and 8. Same amount of values we did for the less than. And then here, I have these numbers here, and there's some decimals because the cube roots are sometimes hard to find. I don't know them off the top of my head, but see here, cube root of 4 is 1.58. Cube root of 5 is 1.7. Cube root of 6, 1.81. Cube root of 7, 1.91. And then cube root of 8 is 2. So you can see that I have those values written down there. I just didn't want to spend too much time on that, but that's how you could do that. And on a section like that, you would always have a calculator. And then on the back is where I did the graphing. So the first part you can see here, I actually did the graphing incorrectly because this point, when you go over 2, is actually positive 2. So the graph will look more like this. But what I would have done is I had the values 0, negative 6, 1, negative 4, 2, up to, or over 2, up to, and then over 3, up 12. So I can show here, but I didn't have to go all the way over to 4 because it doesn't have an equal to, or the line would. And then obviously for the 4, it's just a point at 5. So over 4, up 5. That's pretty self-explanatory there. And finally, for the 5, 6, 7, and 8, you can see that it's increasing ever so slightly, but really not by much. And I tried to show that on the graph as well as I could, but yeah, there'll be a slight increase in that time span. But also, this function is not continuous because you can see that this graph would have been up here, even though there would be a hole there, and since these functions didn't actually equal 4 because the 4 was at the 5. So yeah, that's about all I have for you guys today. And yeah, thanks.